How's it going, everyone? Welcome again. Eulier Gonzalez here, and today we're gonna take a look now at this particular problem called is the longest common prefix. So this is a very interesting. It's also easy, and a lot of company actually ask this particular question. It's just as a way to see how is your thinking process when it comes to work with strings. Okay. Actually, there are two solutions here. In fact, there are three solutions. You got now the brute force solutions or the sorting, as well as something called try or tree. I think you can say that try. Why is that? Because this last one, which is a bonus features, is something that you can use as a way to solve this particular problem, which is a very in-demand problem, especially anytime you hit any e-commerce application and you want to find is, for example, you are looking to buy some food for your dogs or your cat, right? So you put at least is the brand of that, and now it's going to recommend you all of the brands according to that letter you put in. So this is something because a lot of times this is a feature that is heavily used and heavily in demand. Uh, there is a particular data structure to solve that problem. That's to me the most interesting thing of all of this. But uh, this is now the roadmap as we took as a way to actually understand and to make sense how do we going to use all of this, particularly data structures and algorithms, as a way to solve them or as a way to look what is the pattern behind the scene anytime we need to encounter some common problems uh, and see when we can apply them. So for example, data structures like array, hash, set, stacks, queues, and then you got linked lists. Uh, then you got this linked list, trees, tries, heaps, as well as a graph. So all of this, we can talk about this particularly two data structures, like the static data structure and then the dynamic data structures. And then is now the algorithm, the most common algorithms that we're gonna use. So for example, like searching and sorting. All right. So for example, in the case of sorting, a sorting algorithm, we can also take a look at the big O for that because this is what is the most common thing that we're going to do, right? There is actually that particularly. There you got it. Oh, it's like they crashed it. Ooh, they crashed it. Interesting. Angular used to React automated migration. That's interesting. Angular JS is no longer supported. Ooh. Performance boost with virtual DOM, incremental adoption. Oh, as a way to migrate that. Automatic migrations. That's interesting. Up to 10,000 lines of code change. shared tenant in second cloud, GitHub integration, and that kind of thing. Everything in the starter plus, unlimited lines of code change, custom models, unlimited users, private Discord and repo. That's interesting. That's very interesting. And I get it. Yep, I get it. Yeah. So in any case, this is actually quite interesting. They actually promote that as a way to say, hey, you know what? You should do that. The idea here is by looking is that this particular algorithm, which is the way of how most of the time we can now is sort elements or searching. So this is the common structure or the common algorithm that we're going to use most of the time in our career. So for example, like sorting or searching, right? So here, if we're gonna use a sorting, depend on the implementation, we usually need to consider is always the worst case scenario. So because most of the time, the vast majority of the algorithm or method that implement this sorting algorithm, or whether it's they're using merge sort or heap sort, in the worst case scenario is in log n, which is bad. Right? Is almost linear. Is almost linear. So again, it is greater than linear time. So linear time is fair, log n is excellent, as well as constant time, right? So because of that, the the more items we need to process, we need to sort or to interact with, the better off or the faster it will be processed. So because of that, all right, and actually that's not longer available. That's interesting. But yeah. Cracking the coding interview. Who made this? Really? It was her. Holy moly. He's an author, consulting, and founder focusing on improving tech hiring for both the interview and the candidate. Gail has worked as an engineer for Google, Microsoft, and Apple. Most recently at Google, she served on the hiring. Oh, that's quite interesting. I never thought that would be a woman. And in fact, I really like it. I really love the idea. I really love the idea. The other is cracking the tech career. Okay. That's interesting. That's very, very interesting. And it's because all of this, but it is interesting because all of these techniques that we're learning through this is something that perhaps you're not going to apply in your life or in the world, okay? But it's important to know that those things actually exist. So in any case, because this roadmap is based on the NeetCode, which is made by Nadeep Singh, a software engineer that has previously worked as Google intern, and then then I need to take a look at this. Anyway, so he worked at Google, and now has this particular company where he also is teaching about now this how you should actually starting, especially if not only if you want to crack the coding interview, but if you want to know how to develop this sense, this second nature when it comes to solve particularly problems in computer science, not only as a way to crack the coding interview, which is something important, but also as a way to now see when what is the most common use case for these data structures, algorithms, as well as the techniques that you can use. And I think this is one of the best things that we can go for. So arrays and hashings is a data structure similar to the stack as well as a linked list. But then inside of that you get now these particularly techniques that are actually helpful when it comes to solve problems related to this one. To use an array or a stack, or particularly to an array or to linked lists. Right? So the two pointers, as well as the binary search and sliding window. And then how you combine them to actually see how by using now three data structures as a way to represent and be helpful to come up with some solution to help you to come up with some solutions for specific problems. And then you get now is a particular data structure like tries, which is something that we can use, but we are not going to do that. Backtracking, and as you can see, all of the things that are widely used for interesting, even for graph, that are widely used not only in your daily life, okay? The text square, multiply strings, happy number. But also something that are actually in demand. All right. But for this particular case, our methodology here is that we're gonna take the first 40. We're gonna take 45 minutes. The first 10 minutes is as a way to recap what were the problems that we already solved, what is the value proposition of each one of them, and then how we're going to solve this at least at 20 minutes after the intro to see how we can solve those particularly, or in this case, these specific problems. If we couldn't solve that, there's no problem. Then we're going to see is a solution, because the idea here is that it's not necessary you to remember that. It's to see what is the pattern that arises and how you can solve when it comes to deal with them, right? So let's get into this. So because even over the couple days before, we have saw it, for example, contains duplicate, valid anagram, and two summed. The TLDR, or the valid proposition of each one of them, is to start to see how you can use this now sets, as well as hash, in combined with array, and use now some mathematics as a way to see how you can actually is determine a target, or to add to know the two sum of two numbers in a sequence. The TLDR is that hash are helpful when it comes to use by or counting or compare, or when we need to group collections of data. As well as we also look at the k most frequent elements and string encode and decode as a way to see how you can now is put some data inside of, particularly with the top k frequent elements, how you can use the bucket sort, or how you can starting to see, or how you can now represent is hash by counting all these elements, and then using an array as a way to represent is the number of occurrence to that. But the thing here is that uses that structure as a way to represent something. Representation here is the key. Similar with a string and decode, what is the minimal information that you must add to this string as a way to encode? So when you want to decode that, you can now extract that data easily. Similar for the product array except self, valid Sudoku, as a way to see how you can now is represent is portions of or of geometric, or in this case of matrix. All right, similar to the valid palindrome, as a way to see how you can actually is, because this has two particular problem solution. They have two problem. This is a problem you can solve with two particular problems, or with two particular solutions, the two pointer solutions, as well as the regex in character class. I also started to see how now we can use is stack for that. Let me actually put here, for example, stack for that. That's right. And as a way to use now a hash to compare that all of the elements that we already added, and then check if we successfully are removing elements from our stack based on a condition, based on our hash map. And then we look now at the two sum. That input is sorted as a way to start to see how you can now use this particular problem solving technique, which is the two pointers. Right? So these two pointer techniques, is starting to see how you can now use this particular problem solving technique as a way to anytime you need to find pairs of elements and compare and do some condition to check that. But anytime you need to find that, how you can actually is use the two pointers as a way to see this particular pattern, as a way to solve this problem. Actually, this is the way of how this is how our collection end up being, right? Our algorithm actually end up being. Also, we implement is mean stack as a way to stack or to store is the mean element in our stack. Okay. And also how most of the time when you use a particular data structure, it reduces the amount of logic that you need to, because this data structures enforce is policies, enforce is ways to organize data. So with these rules, you can make it much better predictions about how you're gonna get the data, what is the data that you're gonna get, fill in, and so on and so forth. The other is the two pointers here. We're now with this two pointer technique, again, best time to buy and sell stock. The idea here is to check that and update based on a particular condition. Similar with the container with most water, all right? And this was quite interesting because it's check if the sentence is a paragraph. I think there was no challenge, by the way. In fact, it was more like a reflection. Okay, it was more like a reflection. Use set when you need to verify uniqueness. Find all duplicate in an array. Unlike the other one, reflection here. Exactly. Unlike the other one, here, final duplicate in an array. This one was quite more interesting because we needed to work is in place with the input array. So because of that, given the constraint, how given the constraints, we can now, or giving certain constraints, we can use negative, or we can use sign, positive or negative. Okay, we can use we can use is sign symbol, positive or negative, as a way to identify, exactly, positive, negative, as a way to identify if we visit that number, so we can, exactly, as a way to identify if we visit that number, so we can identify, if we visit that number, so we can identify duplicates, but again, giving a specific conditions. So here, the challenge is how to implement a tree, all right, as a way to now, anytime you need to work with prefix or suffix in a string, how you can start to develop this particular sense, right? So because of this, write a function to find the longest common prefix string among an array of string. If there is no common prefix, return an empty string, right? So because we already have this particular values, okay, and we also have another values like this, all right. Here there is no common prefix. For this there is no common prefix, but for this it is common prefix, okay? So if we sort our string where we're going to have now all of them sorted from the smallest in a lexicographic order, from the smallest to the greatest. In other words, so for example, if we have another example here, let's say now we got a, and then we got is aba, like the group, right? Say aba, and then you say abacus. I think it's abacus. Abacus. Exactly, it's like abacus. Wikipedia. Abacus architecture. Well, in any case, Aba, or you say apple, and abacus, or n, the word n as well. So the idea here is that if we have now these elements already sorted, okay, we're going to guarantee that no matter no matter no matter the length of the string that we receive here, we only have is always the lesser the minimal value length here, and the greater strings at the last, right? And if you don't trust me, because you think I lose my mind, let me actually see that this actually won't work as expected. So we put now here apple, right? And you say it's n. All right, then I say sort alphabetically. Then you say, hey, boom, bam, I hear it, right? So because this is the way how now this sorting algorithm works, all right? And once we do that, what we have to do is to now compare is the first position with the last we need to compare this now is the, or this is something known as the vertical. Yeah, we're gonna do is this. We're gonna do is the vertical comparison. So we're going to now iterate as long as the length. We're going to iterate as long as the length of this is of this m string, all right? So we don't actually need to iterate through all of the elements as a way to check each one of them, because we already have them sorted. So a brute force way will be is to, well, let's go to compare now. For example, here if we say flower like this, we say flow, we say fly, because we already know that FL is the prefix for all of this word. If we don't sort it, we will need to actually compare this element with this another element with this another element, and then compare this another element with this another element with this another element, all right, and so on and so forth for all of the elements. So that's not an efficient solution, and because of that, if we sort this, all right, if we say, hey, let's go to now sort this, and let's gonna sort this by flow initially. Why you are doing that? By flow initially, and then flight, because this is the way I have it ordered. That is the length. The length, and if you don't, so just to double check that I didn't lose my mind. There's a way to sort this. as you can see, is initially is flight. Yes, is flight, flow, and flower. So is okay. It start with the fi like this. All right, flow and flower. All right. But as you can see here, now because we already have this order, we can just compare the first element with the last element character and see if they are the same, because now they are grouping. By sorting all of these elements, we are grouping into a common prefix. So what can we do here is this. Initially, we're going to sort these collections of elements. So by sorting that, we're gonna say is sorted array. All right, because I don't want to mutate is the input array. We can do something like this. I'm not sure actually if this is something that is supported. Sorted array. I would like to. I definitely would like you to do that. Let me actually see if this is supported. It says, hey, you must return something. Well, let me return is the sorted array. Okay, it's because you don't recognize that. Yeah, you don't recognize that. To sorted, even though that this is something that actually exists. Because the whole point of to sorted is to create a new copy of that. To sorted. So it's not mutating, it's the current array. No, it does not. It doesn't exist. Okay, it doesn't support that. Well, it doesn't matter. So it must be something like this. Exactly, it's an array of string. That's right. Yep, completely. Okay. But the idea here is that actually this sort our collection. Okay. So because we already mutate this sort, we already mutate this entry, in this input array. The idea here is to now take a look at what we're gonna do with that. Okay, that's the question. So here we can say is, let me actually now define something called result. All right, where this will be is where we're going to store of our prefix, and then now that we already have this sorted array, okay, we want is to now compare is the first and the last index. So by that, I'm gonna do something like this. Const let I is equal 0, I plus plus. In this case, I just want to iterate, but for the length of that string at that initial position. All right, which is, I just want to make the index, I just want to sort that. I just want is to now iterate through that sorted array dot length, or in this case until the first element. Okay, I want you to now iterate through that and the idea of this is because since I want is to now iterate through the first element, or in this case it'll be like this because it's already sorted. I want it to iterate to the first elements of that sorted array, okay, which in this case it'll be like this. All right, dot length, since this is a string, I want you to iterate is until that last element initially. So and now I want you to compare is the first element at this position with the element of the last position of our string array, of our sorted array. So let's go to do that. So we want is to now compare is the first element of our array here, 0. We want to compare is the first element here and the first character. Okay, right, we want to compare that with the last element. So we can say is to improve readability, first element here. We do something like this. Exactly. So first element, sorted array, and the other will be is now the last element, which is last element. That's right. Sorted array at that last element. Okay. This is a way to iterate through that, which is the first element, and this is the last element, which is the sorted array dot length -1. I just want to get is the last element. All right, and we want is to compare is now their characters, which is first element character is the first element character at the first position the same as the last element character at that position. All right, if it is, okay, if it's true, okay, so now let's go to add the result to that, which is in this case let's go to add is add that with the with the value at that moment. It can be first or last, is indistinguished, but we want is to actually get that particular char at that moment. That's right. So I want you to now do this. All right. What I would like you to know is, in this case, if they are different, please, I just want you to return is the result. So break that. All right. Otherwise, Well, actually is updated. So there is no need to add this else statement because this is what we're gonna do after we update that. So if they are not the same, they're actually going to return that. If they're the same, they're going to continuously do that until those characters actually are not the same. So the time complexity here is initially n log n, because when you're sorting elements, depending on which sorting method that you are using, whether it's merge sort, quick sort, the worst case scenario is that if you're using, for example, radix sort, you can is improve that by n plus k, okay, which is almost pretty much like linear time. And since we are now iterating through here, okay, and since we are now iterating through here, okay, the time complexity of this algorithm is m time, which is now m representing is the length of that string at that moment, all right, which when you add these two, you usually get with the worst performance, where now the worst performance is this, so it makes this algorithm now n log n. And that's pretty much it. And that's pretty much so when we run this code, we say, hey, first element cannot assign result because it is, oh, my bad. Completely right. You're right. And there you got it. Holy moly. So when we submit this, it say, hey, there's a wrong case. Oh, because we need to actually verify if the string is empty, which is if the length of that string is equal to say for some reason it will receive this one exactly. If the length of this is equal to 1, then you're going to return is result. That's what happened. Oh, you're going to return is now is the string. Exactly. Interesting. Okay, so now we need to handle is these specific use cases. Okay. All right. Yeah, because here we need to consider if there are NT values. exactly. But now we need to actually cover some edge cases. Okay. Mm-hmm. It's because it's comparison here. That's why interesting here. So if you're comparing is this one element if this is false, so if they are different, you're gonna return this. Oh, Jesus, I get it. That's my bad. Okay. Because we're going to iterate until that last element before. Mm-hmm. So if they are the same, you're gonna do is that. So if they are the different, you're gonna resolve that. So let me actually take a look at this.
Hey everyone, welcome back in time. So we'll go to the inbounds of the first string because that's what we're iterating through up over here. But immediately return. That's how Python works with the conditionals. If the first one is true, we don't even check the second one. And so that is the entire logic head and return.
So if the first elements are, if they are different, return the response, or if the index is equal to the length. You can say or the index, okay, or the index is equal to the length, which means that we already reached the last element there, which is sorted array dot length -1. So in this case, if we do this, for example, okay, and to me this is quite interesting.
To string-based problem using the quick sort algorithm, and that works in an order of n log n time, right? The space complexity of this solution is order of 1. That is because we are not using any extra space to arrive at our answer. I hope we are not
Yes, but it's quite interesting. It's quite interesting. We can do something like this. Let me actually put this at last element, right? Where we are essentially are saying is this. Hey, I want you to now append that element. This is the first element, the last element, all right? And then I want to now iterate until the first element. So it's pretty much doing this. Until the first element. It's like, hey, if they are different, okay, I just want you to break. And otherwise is exactly, if they are different, I want you to break or to return the result. Otherwise is return the result here. So when you submit this, it actually worked as expected. But it was do our logic here. It's because our logic here. So it's quite efficient, by the way, this algorithm. But the whole point of this is to get the first element, get the last element, and then you're going to iterate for the first string until the last one, and then you're going to compare that with the first and the last, first and the last, first and the last, first and the last. So when you find any different, so if they are the same, all right, that's going to add that element to our result as it is. That you're starting to encountering all of its prefix. If not, well, you're going to now append that. So you're gonna break and then send the result to that. So this is using now a string. There is an alternative solution using tries, because tries are most of the time useful when it comes to solve is particularly problems related to prefix postfix in string as a way to find what is the most for auto completion features. So yeah. That's quite interesting. That's quite interesting. LCP array. That was interesting. So in any case, this is actually how you can solve this particular problem when you encounter here this thing. So that'll be all for this video. Take care. Bye bye.